All right, so if we were in person, we did a demonstration. If you're at home and you want to try to watch the video of the demonstration, there is a YouTube video showing about putting two tacks in a paper and drawing an ellipse. It's kind of cool to see that this actually does something. All right. On today, our learning targets are to be able to graph, find the center, foci, and all vertices, both the vertices and the co-vertices. And then we're going to complete this square, and we're also going to be able to eventually write the equations, and some of those are going to be in a separate video. All right. Everybody have their blue sheet out? Do you remember, it's been a while, but when we did hyperbolas, what was in the middle between those h and k quantities? In between there, it was some messy quantity over a squared, but it was minus. Do you remember that? Can you find hyperbolas on your reference sheet? I think they're on the side all by themselves, right? On hyperbolas, this is a minus in here, okay? And then it mattered, the a squared was always the one in the first quantity. But when we change this to a plus, you can reverse the order, any order you want. They usually just put the x's first. But this time, the a is always the bigger number. So there's a different definition for a than with a hyperbola. It's on the reference sheet. It clearly says it there. But for an ellipse, a is just the bigger one. So when it's bigger underneath the x, it's longer in the x direction. Does that make sense? When the bigger number is underneath the y over here, it's going to be longer in the y direction, up and down. Okay? And then the other thing that's weird about these is there's a new definition for c. If you go down here to the bottom, c squared is going to be a squared minus b squared, not plus. And that really has to do with the fact that the foci are inside, not outside. Do you remember when we had an ellipse, a hyperbola here? We had to go further out than the rectangle to find the foci. So we did a squared plus b squared. Now the foci are inside, so it's a squared minus b squared. And the order, think about it, a squared was bigger than b squared. So we can subtract in that order. All right, so some things in the real world that are elliptical. The orbits of all the planets, right, are not perfect circles. They're elliptical. This is what's called a whispering chamber. Has anybody ever been in a building in one of the capitals or an older building that has what they call a whispering chamber where you can hear? Nobody? What happens is at the two foci of the ellipse, if you stand at one of the foci, you can hear the conversation someone is having at the other foci very, very clearly. Doesn't matter how big the room is. Okay, it's very fascinating. So the fancy definition is, not so fancy definition is it's a slice of the cone that's not parallel to the base. But the fancy definition here is that if you measure from one focus point to any point on the ellipse and then to the other focus point, and you add those two distances together, it will remain constant. So what stayed constant on my picture over there? The piece of string, right? The piece of string didn't get any shorter or longer. That's the definition, okay? So the piece of string stayed the same distance. When I moved the foci closer, I got a different shape, but the constant was always the length of the string. Okay, so the word major axis simply applies to the longer one. And the total distance is going to be 2a from one end to the other. The minor axis is the shorter one. And the total length is going to be 2b. Center is HK, same as all of these. The foci are C units away from the center. Now, out on the major axis, the endpoints are called the vertices, and on the minor axis, they're called the co-vertices. And you're going to have to list all 4 of those. So you're just going to have to list the ends of the major and minor axis, and the center and the foci. At least there's no asymptotes. Is that the good news? Okay, and there's no crazy 4p value like in those parabolas. It's basically just a circle, but it's been stretched more one way than the other. Everybody have what they want from that slide? All right, so on this side it says the vertices are A units away from the center. So this entire major axis going this way would have a length of 2A. And these would be the vertices out at the ends. If it was a vertical ellipse, these would be the vertices. The minor axis is B units long, so I'll just put it on this picture. This would be a total length of 2B all the way across this way. And those would be called the co-vertices out on either side there. And just for lack of space, I'll go and put foci on this one. Inside on the major axis is where the foci are located. You can write as much or as little on those pictures as you want. I don't care. But this is the biggie. To find the foci, you have to use c squared equals a squared minus b squared. And that is on your reference sheet. So remember to use the reference sheet. Don't just assume you remember, because it's a different equation for ellipses than it is for hyperbolas. Anybody need more time on that one? Everybody good? All right, this will take a second to copy down too, but this is just the general forms. A squared is always the bigger one, remember. So when the bigger one is underneath the x, it's going to be longer in the x direction. When the bigger one is underneath the y, it's going to be longer up and down in the y direction. If A and B were equal, then it would be a circle. If you have to write an equation, don't forget the squareds and that it has to equal 1 and it's a plus, all that good stuff. Okay? Anybody need more time on that slide? Everybody okay? All right, now we're going to try this. So this one is written kind of tiny over here on the slide, but it says x squared over 64 plus y squared over 25 equals 1. So where's the center? Is it shifted left or right at all? No, so h and k are just at 0, 0. Now, which is a squared, the 64 or the 25? The bigger one is a squared, so the square root of that makes a what? And which way am I going to go 8? Yes, because it's underneath the x, I'm going to go left and right. Or if you looked at the formula, it would say 0 plus or minus 8, comma 0. So we're going to end up with plus or minus 8, 0 from the center. And those are the vertices. All right, and the co-vertices are b. Well, what's b squared? So B is, and we're going to go, that's underneath the Y, so we're going to go up and down 5. This graph paper makes me googly. Like my eyes are not. And because the center was just at 0, 0, we end up with 0 plus or minus 5 for those. All right, we can draw this now. Or we could if we could draw at all. Oh my goodness. Well, in my favor, I did hit all of the points this time. One side is a little dented, but sometimes I can't even manage to hit the 4 points. But those would be co-vertices at the top, and you don't have to label them. You just have to be able to write the ordered pairs. Okay, which way are we going to go for the foci? Left and right, because they're on the major axis. All right, so c squared equals a squared minus b squared. Well, a squared was 64, b squared was 25. That gives us 39. So c is the square root of 39, or 6 point something. Can anybody give me a decimal? 6.2. Now, because we were at the center of 0, 0, it's just left and right 6.2. So we'd have plus or minus 6.20. And you could leave it plus or minus square root of 39. If it simplified, you could simplify. It doesn't. You can give me a decimal. I don't care. All right, 1, 2, 3, 4, 5, 6, and a little more. The closer it is, those closer those foci are to the vertices, the longer and narrower the parabola will be, okay? Or the ellipse, something like that. If it was a perfect circle, the foci would be back at the center. Jerica, you have this packet? Okay. Was there anybody else gone that? All right, let's try number 2. What's changing this time on us? Okay, so this is x minus h and y minus k. And where's the a? Yeah, the a squared is the bigger one, so it's underneath the y, so it's going to be longer up and down this time. All right, so where's the center? Anybody? Positive 5, negative 2. 1, 2, 3, 4, 5, negative 2. Okay. And then how far are we going for A? A would be 6, but it's 6 units which way? Up and down. And so it adds on to the y value. So it would be 5, negative 2, plus or minus 6. Can anybody give me those actual ordered pairs? What's negative 2 plus 6? And negative 2 minus 6? Negative 8. So we had 5, 4, and 5, negative 8. Everybody good? All right. And b squared was 9. So b is actually 3 units to the left and right. So that's added onto the x. So it's 5 plus or minus 3, comma, negative 2. So we end up at 8, negative 2 when we add, and 5 minus 3 is 2, negative 2. Does that work with where I drew my dot? 2, negative 2. Okay, if I attempt to hit all 4 of those dots with a smooth curve. Bobbing. Not bad, huh? That one looks pretty good. Okay. Now we got to find C. A squared was 36. B squared was 9. So when we subtract, we get 27. So C is plus or minus the square root of 27, or 9 times 3, so plus or minus 3 square roots of 3. So the fancy name would be 5 comma negative 2 plus or minus 3 square roots of 3. But let's just sketch down some decimals so we know where this is. Let's see, negative 2 minus the square root of 27, or 3 square roots of 3. Negative 7.2, anybody? Anybody else getting that? It's fine with me if you wrote 5 plus or minus, negative 2 plus or minus the square root of 27. Anybody else get negative 7.2, which will be way down here? And then negative 2 plus the square root of 27 is positive 3.2. Any questions? I agree. Other than circles, I think circles are even easier because there's no foci to worry about, right? All right. So I'm going to actually pause the video and let you guys have like 3 minutes to do this one on your own. How's that sound? All right. So this one was longer up and down because the A value was underneath the Y. Okay. You can pause the video if you need to take some notes on that one, but we let everybody do that one on their own. All right, top of the next page. I don't think you need to write any of this down because I am always going to ask you in the directions to find these 4 things, and I'm going to give you a blank for them all on the quiz. Does that make sense? And everything else is on the reference sheet. All right, we are going to skip down to number 4. Can you take a second and try to find some information about this? So we have an x minus h squared plus a y minus k squared equals 1. Is the a squared, go ahead. Okay, so the center is at 4, negative 2. Do you remember what the definition of this distance is out to the vertices here? Yep, the longer direction is A and the shorter direction is B. And where's the A going to go this time? Yes, because it is longer up and down. All right, anybody think they got it? Jeremy, you got something written down? Yeah, you can give me anything you want. You can be the whole equation if you're done. B squared, yep, B would be 2, so B squared would be 4. And you put that under the X or under the X minus 4? How's that sound? Is that what you had? Corbin, did you try the Y part yet? 1, 2, 3. A is 3. So this would be over a 9 because it's A squared and a Y plus 2. Nicely done. Equals 1. Everybody good? Not too bad on that one? Because it was 3 units up and 3 units down. The major axis is 2A long. And the minor axis is 2B. We're going to talk more about that in a second on another kind of question. All right. This one is just rearrange it. If we add 196 over to the other side, we get 4x squared plus y squared equals 196. And then what do we have to do, guys? Yeah, it's got to equal 1. So we get equals 1. This one is just a y squared over 196. Anybody know what the square root of 196 is? 14. Yep, good call. And then 4 goes into 196 how many times? 49? Okay. And you could type 4 over 196 math enter, or you could just divide top and bottom both by 4. Everybody okay with how we're reducing those? They should always come out perfect squares. It doesn't have to be a perfect square, but I made sure the ones that you have to do all are so that you're not like disturbed, okay? If it doesn't come out a perfect square, check for a mistake. All right, we are going to skip down to number 8. Okay, it talks about height and width, not very definitive terms, but for our ellipse, we're going to talk about height as up and down. So this has a total height of 4 up and down, a total width of 20 left and right. Okay, so its total length of the major axis is 20. Anybody know what that means? What's A? Yes, this is 2A, and this is 2B. Now, is the height always B and the width always A? No, the bigger one is always A, and the smaller one is always B. All right, so from our center, somewhere over at 6, -1, we went up and down 2, and we went left and right 10. So that this was a total of 20 in width and 10 in height. 4 in height. Sorry. All right, anybody start us out? Alexa?
4x minus 6 squared over 10. Oh. Or it has to be squared at the bottom, so that'd be 100.
Good job. 10 squared or 100 down here. All right. Anybody got the rest of it? What do you got, Corbin?
Y plus 1 squared over 4.
2 squared would be 4. All right, so this was H, this was K, this was A, this was B, and we just had to remember that the A was going in the X direction, so it went here, yes? Okay, so try number 9. This time it's taller, 16 top to bottom, and a total of 6 across. So Brooke's not here today, otherwise everybody was here. Okay. What's happening? Anybody besides Alexa? Kyle, what do you have down? In the X direction, 3, so A is, or B is 3, I guess it would be, and so B squared is 9. Good job. Naima, do you have the rest of it? Yep, A is 8, so A squared is 64, and it's all got to equal 1. Everybody good? All right. We are going to jump down. There's a video tomorrow. I review some of the things we just talked about, but then I go more carefully over 9, 10, and 11. And I also review completing the square in case anybody missed it, but we're going to go over these real quick today. Then you can just fast forward the video through it tomorrow or stop it. Does anybody remember what we do first? This is number 12. Yeah, we're going to move the constant to the other side. That's a good call. But we're going to switch the order a little bit so the X's are together and the Y's are together. Does that sound right, guys? And then we have to factor. What is the goal of factoring? The coefficient on the squared term needs to be what? After we factor, it just needs to be a 1. So we need to take out whatever's here. We're going to factor a 4 out of both of those. So we'll have an x squared. Watch your signs. If you divide that by 4, you'll have minus 20x plus blank. All right, and then back here, what are we going to take out of those y's? The coefficient of the y squared would be 25, so we're going to take that out, and we'll have y squared plus what? 2y plus blank. And then over here, we're going to have a negative 25 plus a couple blanks. All right, be real careful with your signs. This is a negative 20, so when you take half of it, this becomes what? Yes, x minus 10, and then you square it and get 100, and there's still that 4 out front. So what are we actually adding to the other side? Yeah, this teacher, the student observer today said she puts the number in the parentheses that was in the parentheses over there. So 4 times 100, just to remind yourself where those came from. Plus, okay, what about the second one back here, guys? Half of this would be plus 1, and on a really good day, 1 squared stays 1, not 2, right? And when we go to add it to the other side, it was a 25 times a 1. Anybody know what that mess becomes over there? Just 400, yep. And then we have to divide everything by 400 so that it can equal 1. So 4 goes into 400 what? 100 times, and we end up with x minus 10 squared over 100. And 25 goes into 400. Anybody know how many times? 16. Yep, good job. All right. Which way is this longer, up and down or across? Across, right? Because a squared is the bigger number and it's under the x term. Everybody okay? All right. I want you to do number 13 right now. Yes.
So, I think it was 16 or 20.
We had a 25 up here and a 400 in the denominator. So you can literally type 25 over 400. Math, enter, enter. And it reduces to 1/16. Or you could just say, does 400 divide by 25? And then you get 16. And so you're reducing the top by 25 and the bottom by 25, and it becomes a 16. Does that help? One of those explanations? You don't want any coefficients on the top. Okay. All right, guys, can you work on 13? And if you finish 13, can you go back and do 7? If you are really struggling with this, completing this square stuff, please ask for help, either from me or from someone else, because it's going to be on every section of the quiz. What'd you get for the grand total before you divided? $324? Okay. Let's see. 36 maybe? Is this one 36? And 81, I'm thinking I got that one. So it is longer this way, going side to side. All right. I won't go back and do number 7 on the video, but I would like you to work on number 7 right now. If we have time, do we have time? But your practice tonight is to do 1 through 3 and number 5 on worksheet 7, okay? 1, 2, 3, and 5. Because that's on the video, the writing equations, I was worried about finishing today, so I saved that for a separate video. Okay, I hope I paused the video. Where's the video? Did I mess this up?